This video will cover Year 9 Maths Applied Pythagoras and Irrational Numbers test preview. I'll put some time tags below so you can skip to the question numbers or question types that you'd like some help with.
Pythagoras is a really powerful tool, and it's usable with right angle triangles, and it's really great if you've got an unknown side. There are a couple of rules though to Pythagoras, and that's that this long side here is called the hypotenuse, and it's always the longest side of the triangle, which also happens to be the one that's opposite the right angle. So this little square here identifies that this is the right angle in this triangle. And you've got a formula which is c squared equals a squared plus b squared. And the reason that it's important that you identify the hypotenuse is that one is always your c value, okay? Now, a and b are interchangeable, it doesn't really matter, okay? But the hypotenuse must always be c in this formula. So what we do is we sub our values in. So we've got x squared in place of the c equals 3 squared plus 4 squared, which is 9 plus 16. So x squared is 25. Now I don't want to know what x squared is, I want to know what x is. So we're just using the balance method here. All I'm doing is the opposite function. So instead of squaring, I'm square rooting both sides, and I find that x is 5. In this second example here, you notice that the hypotenuse, we already know the value. So in this turn, what we're doing is we're hunting for a side that is not the hypotenuse. So what we're going to need to do is rearrange our formula. So c squared equals a squared plus b squared. You could just go ahead and sub the values in and then use the balance method, or you can rearrange it before you start, and that's probably not a bad idea. So let's go ahead and label them. That can be c, that can be b this time, and that one can be a. What I'm going to do is I'm just going to subtract b squared from both sides to rearrange my formula, and I'll have a squared equals c squared minus b squared. The alternative is to just remember this formula and just jump straight in with this one. And now we just sub in our values. So we've got that a squared, which is our unknown, so our x squared equals our 10 squared minus our 6 squared. So we've got x squared equaling 100 minus 36. So now we know that x squared is 64. I don't want to know what x squared is. I want to know what x is, so I'm going to square root both sides, because square root is the opposite to square, and I find that x is 8, and I'm just sneaking off the page. A squared equals c squared minus. Question 1 asks us to identify which of these are irrational numbers, okay? Now we need to know what an irrational number is before we can do that. An irrational number is simply a number that can't be written as a simple fraction. So this one here, this is a simple fraction. This one here, that could be simplified to 9, which is also 9 over 1, a nice simple fraction. This one here could be easily transformed into 14 over 10 or 7/5. But these two here, these are our irrational numbers. And that is because if you tried to simplify this, this would be 5 over 1.73, and then, ooh, that's a funny 3, 7.3, and lots and lots and lots and lots of numbers after that. This one here is 3.14, and lots and lots and lots and lots and lots of numbers after this. This is the one we use in circles. This is pi, okay? So these cannot be simplified into nice simple fractions like these. So it is this and this that are our irrational numbers in this circumstance. Question 2 is asking us to evaluate these, and we're going to do that by square rooting these numbers. So the square root means what number multiplied by itself makes this number, and 6 times 6 makes 36, so the square root of 36 is 6. The square root of 196 is 14. Here where we've got multiple ones, the square root of 1 is 1, and the square root of 16 is 4. So 1 plus 4 is 5. And over here, the square root of 25 is 5, and the square root of 144 is 12. So the answer is 5/12. Question 3 is asking us to answer these as entire surds. That means that our answer has to have all numbers underneath the square root symbol. The only thing is we like to leave any negatives out the front. So I'll show you how that works. When you've got a surd multiplied by a surd, you're allowed to multiply the numbers that are within the square root symbol. So this is really the same as saying the square root of 5 multiplied by 6, or the square root of 30. Over here, don't forget there's actually a little imaginary 1 here. Well, not imaginary, there's really a negative 1 here. Okay, so we can't forget this negative, but we're going to leave that out. That means that what we're going to have is we're going to have the negative square root of 7 times 11, which is the negative square root of 77. And then when we jump down here, to make these entire surds, I'm going to need to get this in here. Okay, now remember, in order for it to escape the square root symbol, it has been square rooted. So to get it in there, we're going to have to square it. Okay, so 4 squared is 16. So this will become the square root of 16 when that jumps in, multiplied by 2, okay, which is the square root of 32. And then when we move on, we've got negative 5 over here. We're going to leave the negative outside. A negative 1 here, okay, so we can't forget this negative, but we're going to leave that out. That means that what we're going to have is we're going to have the negative square root of 7 times 11, which is the negative square root of 77. And then when we jump down here, to make these entire surds, I'm going to need to get this in here. The first two examples in question 4 are the opposite to question 3. So question 3 was getting us to write as entire surds. Okay. Now what we're trying to do is strip stuff out of the square root symbol. Now the way I do this, and there's multiple ways of doing this, is I basically, in my head, I run up all my squared numbers that I know, because they're usually low ones. So I'm running up, 1, 4, 9, 16, 25. Oh, 25 is a factor of 50. So I know that this is really the square root of 25 times 2. And I know that the square root of 25 is 5. So I can now take the 5 out of the square root bracket and answer that question like that. So again, in this one, I'm running up looking for factors of 45. 1, 4, no, 9, yes, 9 5s are 45, so the square root of 9 times 5 will work. The square root of 9 is 3, so I can have 3 outside of the square root of 5 as my answer. Alright, moving on. Down here, when we simplify these, because I've got 7 groups of the square root of 3, and I'm taking 11 groups of the square root of 3 away. It's a little bit like algebra, this one. These are like terms, if you like. Because these are the same, I'm allowed to just do it as a simple subtraction. So 7 groups take away 11 groups. I'm left with negative 4 groups of root 3. Question D is a little bit different, okay? This goes back to sort of question 3. You're allowed to multiply these guys together, and you're allowed to multiply the numbers out the front together. Remember, this is actually a 1 here, okay? We just don't write it in. So we say 5 times 1 is 5, and then 3 times 7, just to make it nice and clear. So this will be 5 root 21. Question 5's got a simplifying. There's a couple of different ones here to have a look at. There's a couple of ways of thinking about this one, but this is probably the clearest. Remember that this is a 1 here, okay? So if we have 4 times 1, we've got 4. And then we've got 3 times 3 in here, which is 9. So we've really got 4 root 9. But we can square root 9. The square root of 9 is 3, so it becomes 4 times 3, which is 12. Over here, we're more or less collecting like terms. We've got one group of root 3, and we take 4 groups of root 3 away, so we've now got negative 3 groups of root 3. And then I have negative 33, and I take another 3 away, so I've got negative 36, and that one is simplified. Down here, let's just simplify this fraction. I know that 3 will go into 3 once, so that leaves me root 1 at the top, and 3 will go into 48 16 times, so I've got root 16 at the bottom. But I can square root 1 and I can square root 16, so what I end up with is 1 over 4 in its simplest form. And then this one over here, even though it looks complicated, is actually quite simple. It's just 20 divided by 2, which is 10, so the answer is root 10. A bit similar to when we multiply the roots. Remember, it's just 3 times 3, so this is 3, which is 12. Question 6 is asking us to use Pythagoras to solve for an unknown side. The first thing I need to do is work out whether the side I'm looking for is the hypotenuse, or whether it's one of the other sides. In this case, it's the hypotenuse, the longest side, the one that's opposite the right angle. So I'm going to use the traditional formula, c squared equals a squared plus b squared. Remember, this one has to be C, and then it doesn't matter which one of these you assign A and B, but the hypotenuse must be C. So we've got h squared equals 8 squared plus 6 squared, which is h squared equals 64 plus 36. That means that h squared is 100, meaning that h is the square root of 100, or h is 10, because in this case we can simplify it. Okay, this time in 6b we will be hunting for this side here, and this side is not the hypotenuse, so I'm going to use the rearranged formula, which is going to be that a squared equals c squared minus b squared. So this one will be a, okay, this one will be c, and this one will be b. The only really important thing is that this one is c, because it's the hypotenuse. So x squared equals 26 squared minus 24 squared, and that would be x squared equals 676 minus 576, which again means that x squared is 100, and we know that x will be the square root of 100 because I've square rooted both sides, or x is 10. Question 6c, I'm hunting for a hypotenuse this time, the longest side, the one that's opposite the right angle. So I'll go in with c squared equals a squared plus b squared. That means that h squared is going to be 5 squared plus 4 squared, which is going to be 25 plus 16. So h squared is going to be 41. I don't care what h squared is, I want to know what h is, so it's going to be the square root of 41. We can't do the square root of 41 without it turning into a long decimal number, so we'll leave it here as an irrational number. 6d, I'm looking for a side that's not the hypotenuse, okay, so this is the hypotenuse here. There's no right angle marked here, but it's assumed because we're studying Pythagoras. So any one that doesn't have a symbol in here is still a right angle triangle, okay? Unless it's asking you to determine whether or not it is. So we're going to use the rearranged formula. So in this case, it's going to be a squared equals c squared minus b squared. So we're going to have p squared equals 7 squared minus 4 squared. So p squared will be 49 minus 16. So p squared will be 33. That means that p will be the square root of 33. We can't simplify that any further, so we'll leave it as it is. In 6e, they're starting to get us to work with surds, okay? So we're going to think about this fairly carefully, and I'm going to slow down. I'm looking for the hypotenuse, so I'm going to use c squared equals a squared plus b squared. My hypotenuse is h, so h squared is going to be a squared plus b squared, the square root of 10 squared. Now remember, the square root of 10 times the square root of 10 will make the square root of 100, which is 10. Remember that the squared and the square root cancel one another out. So watch closely in the next line. H squared will be 7 squared plus 10, okay? Because they've cancelled one another out. So, moving on, h squared will be 49 plus 10, which is 59. So h squared is 59, meaning that h is the square root of 59. And that is as simple as we can make that question. Question 6f, we are looking for the hypotenuse. So we are going in with c squared equals a squared plus b squared. So h squared will be 4 squared plus 2 squared. So h squared will be 16 plus 4, meaning that h squared is 20. And to give myself enough room, I'm just going to duck up here for a second. That means that h will be the square root of 20. But rather than finish here, I think we can simplify this a little further. If I think of the factors of 20, I know that I can do 4 times 5, and I can square root 4. So that means that the simplest answer will be 2 root 5. In 6G, I'm working with surds again, and I'm trying to find a side that's not the hypotenuse. So I'm going to use the rearranged formula, a squared equals c squared minus b squared. Don't forget this one has to be c because it's the hypotenuse. So we've got a squared equals square root of 25 squared minus the square root of 7 squared. Now remember, they cancel one another out. So really what we've got here is a squared equals 25 minus 7. Okay, and you can omit this line if you like. That means that a squared, is 18, or that a is the square root of 18. Now I think we can better this a little bit, so let's just duck up here for a second. That means that a is, if I think of some factors of 18, 9 times 2, and I can square root 9. So the best answer is a equals 3 root 2. 6h is a great question. We're trying to find x, but we just don't have enough information in this triangle to find it yet. Okay, so this is going to be a double stepper. There are 2 right angle triangles here stacked on top of one another. Okay, and we're going to assume that this line here is equal, that these triangles don't quite line up, but we know they should. So I need to find this first in order to find this one. So what I'm going to do is I'm going to add my own letter in here, okay, so that I don't get confused and so my marker knows what I'm up to. Now I'm going to ignore this triangle altogether up here, and I'm just focusing on this one. I've got 2 pieces of information. It's a right angle triangle. I can find the unknown. It's not the hypotenuse, so I'm going to use a squared equals c squared minus b squared. Okay, remembering this is c, okay, and this one's b, this one's a. So y squared is 9 squared minus the square root of 11 squared. Okay, so in other words, what I'm really looking at is y squared equals 9 squared is 81, and the square root of 11 squared is 11. They cancel one another out. So that means that y squared is 70. Before I go any further, I'm going to halt just here, okay? And now I'm going to start working on this second triangle, okay? Because I know I'm going to add my own letter in here, okay? So that I don't get confused and so my marker knows what I'm up to. Now I'm going to ignore this triangle altogether up here and I'm just focusing on this one. I've got two pieces of information. It's a right angle triangle. I can find the unknown. It's not the hypotenuse, so I'm going to use a squared equals c squared minus b squared. Okay, remembering this is c, okay, and this one's b, this one's a. So y squared is 9 squared minus the square root of 11 squared. Okay, so in other words, what I'm really looking at is y squared equals 9 squared is 81. And the square root of 11 squared is 11. They cancel one another out. So that means that y squared is 70. Before I go any further, I'm going to halt just here, okay? And now I'm going to start working on this second triangle, okay? Because I know really